Hey, welcome to the Fresh Code Man. And today we will be looking at the union find algorithm. And we will be looking at it, how it works, and then we'll solve some problem based on it. And that's the content for this video. Let's start without. Okay, here we have the union find algorithm. As the name suggests, union, that means you will be making the union of two sets, and find means you will be searching some sets which is belong to which sets. And algorithm is it is a set of instruction. So as per this particular algorithm, this is used like in many places, like to find the connected graphs, right? And to find the number of connected graphs. Yeah, and it is also used in finding the minimum tree in Descartes' algorithm. So those are the use cases, but how it works, that is the important thing. So it is it works like this. Suppose mm, you have some nodes here. I'm just taking an example of it and then we'll solve that. So you have two nodes, and if you have been asked 0, 1, 2, 3, you have been asked that tell us how many of the nodes are connected, or how many disconnected graphs are in this particular graph. Okay. Then how will you going to do it? So as per the definition of union, you will be creating a uh, n number of islands. So you will be creating n number of sets. You will be saying, okay, let me create one set for 0, one set for 1, one set for 2, one set for 3. Now all of them are disconnected. We are assuming that initially, and then slowly we will union them or merge them to each other as per they are connected or not. So if 0 and 1 is connected, then we will going to merge them, 0 and 1. And if 2 and 3 is there, then 2 3. And now we can say there are no other ways to merge more. So this is our final graph. Okay. So now we can say there are two disconnected graphs here, or subgraphs here. But when you write this algorithm, you don't actually create these sets. Instead of that, what we do is, let me tell you that we create some parents, and okay, that the thing we can do also. So in actually what we do is we create a parent, and parent will have all these keys like 0, 1, 2, 3. And then we also create a rank. Rank will tell you which one is higher in the rank. Okay. Okay. So initially all of them have rank 1, and initially all of them have initially parent as self, because they haven't grouped it with anyone up until now. Now, as soon as algorithm starts, what it says is, mm, it will be if we are saying, okay, find the 0, then the parent of the 0 will be 0, right? And the parent of 1 is 1. But when we are say, okay, now we know 0 and 1 are the connected, so we will make them, let's make them union 0 and 1. So if you want to make the union of 0 and 1, what will happen is the parent of both will become the same. And how that going to be, and that's depend on the rank, which parent we will going to choose. Suppose here we also have 4. 4, 4. Okay, fine. So now, if we are unioning 0 and 1, so we will check the rank at 0 and rank at 1. If any of them have the greater rank, that the case will come later when we reach to the 4. But right now, when the rank is equal, then what we do is we can either of them set as the parent. So we will set the parent as this one, as now the parent for this one is increased, and we also increase the rank for zeroth, and we move ahead for the next link, that is 1 to 4. And now we will going to union the 1 and 4. We will check if the parent of 1 and 4 is same, then we don't do anything because they are already merged. If the parent are not same, then we'll try to find the parents, right? And if they are not same, then we will merge them. Let's see. If we are merging 0 and 1 and 4, you will see, okay, 1 is there. Sorry, last time we missed one thing. We increased the parent by 1, so the rank will be going to be increased for the 1 only. Okay, so here it will become 2. So now we are looking at the union 1 and 4, union of 1 and union of 4. So we will see if the parent of 1 and 4 are same. No, they are different. If they are different, then we'll merge them or union them. How we're going to do? We will look at the rank of both of them. One have the 2 rank and 4 have the 1 rank. Okay. Then we will see 4 have the 1 rank, and we will see which have the higher rank. One is have the higher rank, then we will decide to put the 1 here and increase the rank of 1. And then we come to the last link, that is the 2 to 3 link or edge. So what we'll do is we will check if the 2 or 3 parents are same or not. If the parents are same, we don't unite them. If they are not same, then we'll going to unite them and we'll say union 2 and 3, because now parents are not same. So now we'll see both of the rank of them. Okay, both have the same rank. You can put either way, eitherwise. So earlier we put 1, so this time we'll put 3 maybe. It's up to us. So now we put the 3, so we'll increase the rank of the 3 to 2. So now if you say, now it's done, all is done, right? Now if you see union and this, now you can see there are, mm, and we can mark this 0 also, mark it 0, rank as 0, and mark this as 0, mark this as 0. So now we have only ranks for 3 and 2, which have, so we can say there are two provinces or two disconnected graphs. And this is how actually union find algorithm works. So you have two methods. One is called as find. Okay, find the x, that goes like this. If parent of x not equals to x, because initially it was there. So initially parent of 1 is itself. So we are assuming that it is not that one. If it is not that one, then what we will do is, and if it is the same, if the parent is same, then we will do this. We will do this. Return, not sorry. We will find next one. and call it return and find parent of x. Now we'll find parent of x until we reach to the parent. Okay, or else if it is not, then else we will say x parent of x. This is the finding the parent. And if we are going to make it unite x and y, then what we will do, it depend on the root of there. So we will find the root of x बराबर find x root, find parent, find x, and root y बराबर find y. So now we have the parent of both of them. Then we can decide based on the parent is okay. Like similar ways. If you are trying to find the one, what will happen? It will look for the parent. It will look for the parent, okay, wherever it reaches. Wherever it is the same, right? It will reach there. So suppose here we have 2 के लिए 3 है, both are not same. If not same, then we'll say कि 3 को find करो. जैसे ही वो same हो, then we'll return the 3. That's the magic, because we know the because we know it might be possible it is a kind of chain, so that's why. And then when we are making a union, then we'll do root x and root y. Now we know the parent of both. And then if based on the rank root x greater than root y, अगर root x की rank is greater, then what we'll do is we'll do parent के root y में we will put the root x. Okay, if it rank is already greater, then we don't need to change the rank at all. If you want to do that, you can, but you don't need to because the rank is already high. Or if you want to do that, you can, so you get to know ki how many of the nodes are there in the to to calculate the nodes. You can add add that to the state also. And you can also do one more thing. You can do this also. Rank of root x, make it 0. So to count to count the provinces. And then else, if else, if else rank of y is less than rank of x, then do just opposite of it. And if root x बराबर root y both are equal, okay, the parents are same, then what we will do is, now we know the parents are same. You know, roots are not, I'm not saying the levels of x, huh? Not the roots. Okay? The parents, the rank of them is same. If the rank is same, in that case, we will increase the one of them the rank and set others 0, because now that doesn't exist at all. Okay. Okay, cool. So now we know the union find algorithm. Let's solve one of the problems based on it. Okay, so here we have a graph. This you will be having a link in the description for this particular this article. So now we will calculate the number of provinces. Okay. So here is the problem. There are n cities. Some of them are connected in network. If A is directly connected to the city B and B is directly connected to the city A is indirectly connected to the C. If a group of cities are connected directly or indirectly, they form a province. So given n cross n matrix is connected where is I this j barabar 1. If the ith city and the jth city are directly connected and I is connected barabar 0 is otherwise determine the total number of provinces. So what this question is saying is, so you provided a matrix like this. If we copy that similar matrix 110 110 001 and 0012 1 2. So we have a matrix that shows is the is connected cities. Okay, is connected cities. So you have the cities 0, 1, 2, and you have to find out how many cities are connected or how many provinces are there. Provinces means the one province is made out of the all connected cities of it. Okay. So let's see if there are 0 and 1 is connected and 2 is not connected, then there are two provinces, this one and this one. And now we will see 0, 1. Let's start building the diagram. So we have 0 to 0. Yes, 0 to 0 connection we have. Then 0 to 1. 0 to 1 we have. Then 0 to 2 we don't have. Then 1 to 0 we have. 1 to 0 we have. 1 to 1 we have. But we don't have 1 to 2. Okay, then 2 to 0, 2 to 1 we don't have, 2 to 2 we have. So 2 to 2 we have. So now you can see why this matrix we have two provinces. Let's write the union find algorithm for it. What we will do is we will we will create our we will initialize our algorithm by this 0 0 0 0. Okay, sorry, not 0 0. We will initialize our algorithm like for parent we will say okay 0 1 and 2, and for rank we will say uh, 1 1 1. Okay, now we will going to know uh, I already told you if the ranks, or maybe there is one more other way. If we are merging two cities, then we definitely reduce the total number of provinces. Initially, I will be assuming total number of provinces are total number of cities, and we start merging them one by one, and then reduce the total number of province because those cities are merged to some other province already. And this way we also can track it, and there is another way also, we can use the rank to track the number of count at the end, but I will use this way this time. Let's see how it goes. So the solution is here it is. So I implemented it this way. We have created this find x, where what we will doing is if the parent of x is not equal to x, then we will find it further, and if it is the same, then we'll return the x as it is, and that will become the parent for us. And then we are doing this union here, and as I already told you, we will be counting the node on each of the province. So that's why we are doing this much of work, but we don't need to do that, but it helps us. So what we are doing, we are getting the parent of x, parent of y from x and y from this find using the find, and then if if the rank of X is greater than or equal to the rank of parent Y, then if X is greater, that means we will set the parent of Y as a X. So that's what we did. And then we increase the rank of X with the parent of Y. Whatever the nodes were present in the parent Y, that will be added to the parent X. And now we'll set the number of nodes to the parent Y to 0. Okay. Then let's move to the next one. Okay, I think I missed something here. Yeah, so now it's look good. This dot parent x equals to parent y, and then we are doing the same thing, but in the opposite direction. This is the union. And now we have our find union methods. Let's see. So in the constructor, we define parent and rank here, and then in the find province, we are creating the parents. We defined them in the constructor, but we are assigning the values in this find province method by the whatever the length of array it has, and then we are running this uh, for loop. So in the parent, the value of the parent I is the same as its value. Okay, then we are saying, okay, let's find the number of provinces are len, number of n, as I already told you, will decrease the province as we merge, so that will reduce the provinces, right? Then for let I barabar 0, I less than ln I plus plus for every merge, yeah. So let j barabar 0, j less than len, and then if is connected I and j, if both are connected, then we'll try to merge. If the parent of I and parent of j are not same, then we'll merge and we'll reduce the province by one, and then this union will merge them. And yeah, here we are printing the islands. As we said, it will create a island of something. Okay, let's see. First of all, I already have this particular thing here, and let's create the islands out of it, and then we'll see will it follow exactly the same thing here or not. Yeah, yes. Ooh, okay, now it's look good. Yes, or maybe we can increase the more, much more. Cool. Let's start following with Zainalum, and you will have it. So now if I start doing it, so this is our 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. What I will do, I will say 0 to 0 is there. 0 to 0 is there. Then 0 to 1, 0 to 2, 0 to 3, 0 to 4 is there. Right? We connected it. And then next one, 1 to next one is 1. For now, we will check 1 to 0, nothing. 1 to 1 is there. 1 to 1 is there. And then 1 to 2 is there. And then nothing. Then we'll come to the 2. And then 2 to 0 is nothing. But 2 to 1 is there. 2 to 1 is already there. Then 2 to 2 to 2 is also there. Then nothing. Then we come to the 3. Then 3 is 0, 3 is 1, 3 is 2, 3 is 0. Okay, 3 3 is there, so we'll create a 3 3, and then 3 5 is there. Okay, then we'll come to 4 4 1 is there, 4 1, so it will going to connect this way, and then 4 0 4 1 4 4 भी है, 4 4 is there, and then 4 5 is there. Sorry, 4 4 4 is there, 4 0, oh sorry, 4 1 is not there. Okay, let's start from the fourth one. So 4 0 is already there. Then 4 1 4 2 4 3 4 4 4 is there. We already added that. Then 4 5 is there, 4 5, so it will connect it to the 5 fifth. Then we'll come to the 5 0 0 0, and then 4 3 is there, 4 3 already added, 4 4 is there, 4 4 is already added, and then 5 5 is there. So now you will see there are two islands. One island have the uh, two cities, and the another island have the four cities. Let's see how it will occurs. So in our rank, what should happen? It should have like 4 2 0 0 0, something like that. So it have good one. Okay, let's see. We already run the program. I'm running it now. Okay, now it is accepted it. But if you see the console.log here, these things, these will print the parent and rank. Let's see the rank and parent. Go to the bottom. And if you see here, this we have this 4, 2, and 0, 0, 0. And if I submit it, and it is working fine. So this is how you can use the find union find algorithm. And let's move to the next problem. Okay, next problem. Let's copy it first. Okay, let's move to the next problem. How they did it, by the way. They also use union set. They are using this way. They don't need to do the things that I did, by the way. Okay, find root x, root y. Find if not is there, then parent x barabar this dot find parent x, and then return the parent x. Okay. Mm, 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 mm. This dot parent constructor is there. Methods are got created. Then we'll say and connected. You have union find, and oh, they have created a union find class itself separately. Okay, that's cool. So what they do is connected, yeah, the connected and if find one I and find j are not equal to same, then we'll merge it and then degrade the provinces. Okay, cool. It is looks similar to us. Let's move to the next question. Minimum number of vertices to reach all nodes. Given a directed acyclic graph with n nodes level from 0 to n minus 1, determine the smallest number of initial nodes such that you can access all the nodes by traversing each. Okay, we need to find the minimum. Okay, if we use the union find method here, it will give us a minimum wala, because it will going to connect all of them with others, right? Suppose 0 to 1, 0 to 1, then it will connect 0 to 1 and make 0 ka parent 1. Okay, and then 0 ka parent 2, and that's way it will do. Okay, cool. Give me some time.